This is Danny Tang doing the probability homework 8, which gives us the joint density of f of xy is a times the absolute value of x plus y from when x is 0 to absolute value y, and absolute value y is from x to 1. So it looks like the bounds look like this. And the limits of x is from 0 to y, and the limits of y are it has two parts because of the absolute value from x to 1 and negative 1 to negative x. So to verify this is a valid joint density function and find what a is, we have to take the double integral of small f of x, which we did here, and we put in the bounds. So since this function is an absolute value, we have to actually break it into two parts. So we have to consider the positive case and the negative case. And the bounds, if we integrate with respect to dx first, we do 0 to y for the positive case and negative y to 0 for the negative case. So after we do the integration out, which takes a few steps, as shown here, this is still the positive case, negative case, and then we do the integration with respect to y, and then after we evaluate everything, we find that 2/3 a equals 1. To make this a valid joint density function, that means a is 3/2. So we can write that in for small f of x. And to find what f of z is, z here is x times y. We use a formula from lectures, which is we switch some variables around, so we set w equals y, and x would therefore be z over y or z over w. So this formula is from the book. Actually, this has an absolute value sign on it, so let me do that real quick. So in here we replace the x and y with z over w and w. So when we consider z is greater than 0, we can just write this without the absolute value sign. So this is what the integral will look like. And when we evaluate it all the way through, we get the integral is negative z over w plus w, and then we put in the bounds, the limits, and in the end we find that it's 3/2 times 1 minus z. And this is for z greater than 0. And for z less than 0, we switch the bounds and make them negative. And this whole thing is also negative, so the negatives cancel out because we're considering the negative case. And so we get this, and we get the same integral pretty much, or the integrated part for both positive and negative, but we have different limits. So after we do that, we plug everything in. We get 3/2 times 1 minus z minus 2 square root of z.